Okay, let's talk a little bit about acid-base indicators. In a titration, unless you're using some sort of electronic meter, you're going to need an indicator. That's typically done in a lot of general chemistry or even high school chemistry labs where you don't necessarily have a lot of sophisticated equipment. You get into industry, they use a lot of electric meters, but you're going to hit a point in the titration where you have chemically equivalent amounts of acid and base. We call that the equivalence point. That is, based on the stoichiometry, I've added equal mole to mole amounts. Now, a lot of times we use an indicator, which is a color changing dye, to indicate the end of the titration. We call that the end point. That is, when the dye changes color, we stop the titration. Now, those may or may not be exactly the same. The difference in the two would be what we'd call the titration error. That is an error built into the experiment. And the reason is that many indicators are themselves weak acids. And so if 3 drops of indicator is good, 20 is not better. So usually 2 or 3 drops of indicator for a titration. But usually the weak acid version of the indicator is one color, and then the anion is a different color. Or one of the two could be colorless even, as phenolphthalein is colorless in acidic solution, but once you get up to a pH slightly above 8, it'll generally turn pink, which is thought to be the end point. If you overshoot it, you get a dark sort of pinkish purple color. So we could write an equilibrium constant expression where the Ka of the indicator is equal to the H plus concentration times the indicator anion divided by the unionized indicator. So you can get different ones. For example, methyl violet is yellow in the acidic range. Once you get to pH too much above 2, it changes purple. So it's going to determine the pH range you're looking for. So you're going to pick an indicator based on the pH range you're looking for. When's it going to change? Methyl orange is going to be pink to red in acidic solution, but yellow if it gets too alkaline. But in the sweet spot where you want to look for it, it's orange. A lot of times it's used to titrate when you've got a basic solution and you're titrating with an acid solution, adding it to the flask. Litmus is sort of our either or test. Usually if it's acidic, it'll turn it red or pink, and blue will turn it basic. Phenolphthalein we mentioned, colorless in acidic solution. When we get slightly alkaline, it'll turn pink to sort of a reddish purple. For example, methyl violet, you can see it at pH 0, slight yellow color to the solution. But by the time we get to a pH of 4, it's definitely purple. And that would be one example of an indicator in the color change of the dyes.